Good day, everyone. My name is Hatinuke Fasea. Welcome to InterswitchSPAK prep class. Today we'll be looking at metals and non-metals. By the way, I'm your chemistry tutor, so let's be looking at metals and non-metals today. So relax, get your writing materials, and let's do a brief revision of what has been taught earlier in class. Okay, thank you. Metals and non-metals. Metals. Can I have one or two examples of metals? Okay. By now you should know that sodium is a metal, lithium is a metal, magnesium is a metal. Even non-metals, we have examples as oxygen, hydrogen, fluorine. These are common elements you're familiar with in your class. Now, by now you also know that elements are classified into metals, non-metals, and metalloids. Metals, example being copper, mercury, aluminium. These are metals. The non-metals, you have nitrogen, we have carbon, fluorine, etc. The metalloids are elements that are in between metals and non-metals. So they behave, at times they behave as metals, at times they behave as non-metals. Very good example, you have your silicon, we have your germanium, you have arsenic, you have boron. All these can behave as metals and non-metals. They are called metalloids. They are also called semi-metals in some cases. Then this is the periodic table, which are classified based on metals and non-metals. The yellow part is the non-metals, while the blue part is what you have as your metals. Then this red line is trying to demarcate, and that is where you have your germanium, you have your boron, you have your silicon. In a way, these elements are called metalloids, as I've earlier said. Now, we are looking at hydrogen and some other elements. There are some elements that you're familiar with in school. And now let's quickly look at a brief revision on each one of them. Hydrogen is the lightest element known. Atomic number is 1s1. Formula is H2 because it's the atomic element. Atomic number 1, atomic mass 1. Hydrogen, most times you write reactions in class, in school, you remember that hydrogen is very, very important. So let's quickly do a brief recap on hydrogen. We have the laboratory preparation of hydrogen, in which dilute hydrochloric acid is passed through zinc. Now, hydrogen gas will be produced, is a gas, so it's going to pass through to the delivery tube and collected over water. And your dilute hydrochloric acid will run through the thistle funnel down to meet the zinc. Then your hydrogen gas is being produced. The byproduct is zinc chloride. Byproducts are products formed alongside the main products. Then we have industrial preparation of hydrogen. Industrial preparation of hydrogen we have is known as Bosch process, where you have your red hot coke react with steam and water gas. Water gas, the mixture of carbon 2 oxide and hydrogen is known as water gas, in the presence of iron 3 oxide and chromium 3 oxide. This reaction produces our hydrogen. It produces hydrogen. So this is an industrial preparation of hydrogen gas. Hydrogen is colorless, odorless, lightest element known, and the major reaction hydrogen will undergo is combustion. Hydrogen will react or burn in oxygen to produce water. Another chemical properties of hydrogen gas is that hydrogen also reacts with metals. When they react with metals, they give you metallic hydrides. For example, potassium reacts with hydrogen to give potassium hydride. They also react with metal oxides. When they react with metal oxides, example is copper oxide or lead oxide, to give you the metal and water. Then they react with non-metals. A very good example is the halogens. Example of halogen is chlorine. So hydrogen reacts with chlorine to give you hydrogen chloride gas. Hydrogen chloride dissolves in water to give you hydrochloric acid. Another element is oxygen. Oxygen, can you all breathe in? Okay. Breathe out? Okay. What did you breathe in? I'm sure you all tell me air. Oxygen is the most active ingredient in air, and that is why most times we breathe in oxygen, and you say air, but it's actually oxygen that we are really taking into our system. Now, the atomic number for oxygen is 8, mass number 16, symbol is 0, is O, and the formula is O2. It's a diatomic element. It's a diatomic element. Electronic configuration is 1s2, 2s2, 2p4. Let's quickly look at the laboratory preparation of oxygen. How is oxygen produced? Now, if you look at this reaction, we realize potassium triisochlorate 5 reacts with manganese 4 oxide in the presence of heat, boiling to produce the oxygen gas. It's collected over water. Another preparation of oxygen gas is decomposition of hydrogen peroxide. When you decompose hydrogen peroxide, this reaction do not need heat, produces oxygen. It produces oxygen and is collected over water. Okay, now let's move briefly to industrial preparation of oxygen. This is fractional distillation of liquefied air. You realize that in this particular process, it's not only oxygen that is being produced, we have nitrogen as well. So this particular process produces nitrogen and oxygen industrially. So each element has, or each gas, each nomenclature that we'll be looking at, most of them have their industrial preparation and they also have their laboratory preparation. So the fractional distillation of liquefied air will give us nitrogen and also give us oxygen. The air is compressed and allowed to cool, then allowed to warm up again. Then the constituent of air starts separating. We have the rare gases, which is krypton and xenon, then oxygen, then followed by argon, then nitrogen. They are separated based on their boiling points. Okay, properties of oxygen: colorless, odorless, tasteless gas, slightly heavier than air, soluble in water, is a neutral gas, is neither acidic nor basic. That means if you bring your litmus paper, it will not change color. And the major test, oxygen relights a glowing split, which is a test for oxygen. It relights a glowing split. For hydrogen, the test for hydrogen is that it gives a pop sound in a lighted split. Oxygen is very reactive and it combines with almost all elements to form oxides. It is used in breathing, most times to resuscitate life in the hospital, and respiration. It's used in medicine, it's used for welding and cutting metals, it's used in steel, in blast furnace, it's used in steel. Oxygen is one of the most used elements we have around us. We have types of oxides. For example, we have 4 main types of oxides. Oxides are formed when oxygen reacts with elements. When metals react with oxygen, they give us basic oxides. When non-metals react with oxygen, we have acidic oxides. Now, aliphatic oxides are oxides that can behave as a base and also behave as an acid. Then we have neutral oxides. They are neither acidic nor basic. Example of acidic oxide is CO2, SO2, NO2, NO. Basic oxide, we have sodium oxide, calcium oxide, potassium oxide, magnesium oxide, copper oxide. Aliphatic oxides, aluminium oxide, lead oxide, and zinc oxide. Neutral oxide, water, carbon 2 oxide, and nitrogen 1 oxide. These are the 4 types of oxides that we have in chemistry. Another major element that we always look out for is chlorine. Can I hear you say chlorine? Okay, chlorine. Atomic number 17, mass number 35.5. Yes, chlorine has isotopes, and that is why it is the mass number is 35.5. The symbol is Cl and the formula is Cl2. It's also a diatomic element, and it belongs to a family known as the halogen. And other members of the halogen are fluorine, bromine, acetylene, iodine. These are other elements of the halogens. Laboratory preparation of chlorine. In all of these elements, the one that I really like the laboratory preparation is actually chlorine. And why? Now let's look at it. I like the fact that it's a little bit complicated and I enjoy it. Okay. Chlorine is prepared when you oxidize concentrated hydrochloric acid. The oxidizing agent in this reaction is manganese 4 oxide in the presence of heat. Now, the concave Cl being oxidized and produces two things. It produces hydrogen chloride gas and the chlorine gas. Both of them will now move into the next container. Now, hydrogen chloride gas dissolves in water. So automatically your chlorine will be left to move on to the next tube. Now, the function of concentrated tetrahydrosulfate 6 in this reaction is to act as a drying agent. You know, your chlorine has been moisturized, it has gained water, so concave H2SO4 will dry it, and your dry chlorine will now come out as dry chlorine. This is a laboratory preparation of chlorine. Now, what did I say again about concave H2SO4? Okay, is a drying agent in this reaction. What did I say again about MnO2? Manganese 4 oxide is an oxidizing agent in this reaction. Another method of preparing chlorine in the laboratory is using KMnO4. That's potassium tetraoxomanganate 7, KMnO4. But this time around, it will not be used. It will not be used. It's the same process. HCl will be produced. Also, chlorine will be produced. The HCl will be absorbed by water. You are left with your Cl2 and dry by concave H2SO4, and you have your dry chlorine. Okay. Physical properties of chlorine, chemical properties of chlorine is a greenish yellow gas with an irritating smell. It irritates you when you perceive it. It's also a poisonous gas and an acidic gas as well. But it's slightly soluble in water, but quite soluble in non-polar solvents. That's organic solvents. It's denser than air. What do you mean by it's denser than air? By the time we calculate the relative molecular mass of chlorine, that's 35.5 times 2 to give you 71. And the density for air is between 28 to 30 or 31. So you can see that it's much more heavier than air. It's much more heavier than air. And that is why it is collected downwardly. It is collected downwardly. Say downward delivered or upward displacement of air. Then we have chemical properties of chlorine. Dissolves in water to form a yellowish green solution. This is a chlorine solution of water, and it produces two acids, which is hydrochloric acid and hypochlorous acid. Hypochlorous acid is unstable, so it will break down to give you HCl and oxygen gas. Another gas we need to look at is hydrogen chloride gas. Hydrogen chloride gas fumes in the presence of air. Now, it is formed when concave H2SO4 reacts with soluble chloride. A very good example is sodium chloride, and your HCl will be produced. It's a two-stage reaction. The first thing that is to produce sodium hydrogen tetraisosulfate 6. You add more sodium chloride to give you your HCl gas. Uses of chlorine. Chlorine too has a lot of uses. One major use is that it is used to disinfect germs during water purification. That's a major thing. Water purification. Then it's a bleaching agent. It can also be used to produce other chemicals like HCl, polyvinyl chloride. Is used in chemical synthesis as well. Now, another gas that you are familiar with is hydrogen sulfide. Yes, hydrogen sulfide. Hydrogen sulfide is produced when you have your dilute HCl react with a metallic sulfide. In this case, we have iron sulfide. Hydrogen sulfide gas will be produced. It has a rotten egg smell. And you can perceive it immediately it is produced in the laboratory. This is Gibbs apparatus. Yes, I know you are familiar with Gibbs apparatus. You can use Gibbs apparatus to produce intermittent supply of gases in the laboratory. In this case, it is used to produce hydrogen sulfide. Another gas that Gibbs apparatus can produce is carbon dioxide. Carbon dioxide is used frequently in the lab, so Gibbs apparatus can be used to produce carbon dioxide. Okay. One major element that is very nice for us all to know, and it has a lot of compounds under it, is sulfur. Yes, it's a yellow solid. It's a non-metal, but it's a solid, and it's yellow in color. Now, this particular slide you're looking at is known as contact process, which is the industrial preparation of tetraisosulfate 6 acid. Now, from sulfur, you have your air, which is the major ingredient in air. The most active ingredient in air is oxygen. So oxygen reacts with sulfur in a combustion furnace to produce sulfur dioxide or sulfur dioxide, which is your SO2. SO2 reacts with more air to give you sulfur trioxide. This is one of the most important parts of this flow chart, this process. During this process, vanadium 5 oxide acts as a catalyst at 450 degrees C, 2 atm. That's the pressure for this particular reaction. Sulfur trioxide is SO3 and is a reversible reaction. So SO3 dissolves in H2SO4 to give you your helium. That's H2S2O7. H2S2O7 dissolves in water to give you your sulfuric acid. The reaction is what is highlighted down. Sulfur plus oxygen to give SO2. SO2 plus oxygen, the reversible reaction to give you SO3. That's sulfur trioxide or sulfur 6 oxide. Then it's an exothermic reaction. Then sulfur trioxide dissolves in H2SO4 to give you oleum. Oleum dissolves in water to give you tetraisosulfate 6. This process is known as contact process and is one of the most used process we have in industries. This is the laboratory preparation of ammonia. Formula for ammonia is NH3. Yes. To form an ammonia, or to produce ammonia in the laboratory, you need ammonium chloride and calcium hydroxide. That's NH4Cl and CaOH2. Now, when both are mixed together and heated, ammonia gas is produced. moist ammonia, and you dry it in the presence of quicklime, which is your CaO, using a drying tower to produce ammonia gas. Another major process that you are familiar with is Haber process. Can you say that? Haber process. Now, that is the industrial preparation of ammonia. Industrial preparation of ammonia. We have nitrogen from air, hydrogen from natural gas, react together in ratio 1:3 to give you ammonia in the presence of ion catalyst 200 atm between 400 to 450 degree C, and you produce your ammonia. The gases are cooled and ammonia turns to liquid. So this is how ammonia is being produced industrially. And the name of this process, once again, is known as Haber process. Now let's look at metals. Yes, metals. Metals, properties of metals. They're sonorous, ductile, malleable, good conductor of heat and electricity. You all know what metals are, and you have examples all around us. These metals, most metals are produced or gotten as ores. So let's quickly look at ores of some metals. We have bauxite, which is the ore for aluminium, galena, which is the ore for lead. We have zinc blende, and we have sphalerite for zinc. We have magnetite or hematite for iron. We have cassiterite for tin. We have agatite for silver. We have pentlandite for nickel, cinnabar for mercury, and I know sodium means rock salt. Sodium is also rock salt. So these are ores for metals. Now, for us to get the metals from the ores, there are some processes that we need to know. For example, there's a table known as the reactivity series, which arranges elements in order of reactivity from the highest to the least. Potassium, on this particular series, we have potassium as the highest, followed by sodium down to copper. Now, these elements are classified, or metals are classified into three. We have the yellow parts, very reactive. We have the fairly reactive, and we have not reactive. If you can see, we have carbon and hydrogen. They are non-metals, but they are on this table, and they serve as a guide. They serve as a standard. So for those higher than carbon, you regard them as very reactive. Those between carbon and hydrogen, regard them as moderately reactive or fairly reactive. And any metal that falls below hydrogen is regarded as not reactive, or you say less reactive. So elements that are very reactive are extracted from their ores by electrolysis, and elements that are less reactive are extracted using carbon to get them. That's thermal reduction by carbon. The elements that are less reactive most times are gotten in their real form, in their real state. A very good example is silver, gold. These are gotten in their real state. What you need to do is just purify them to get the metals. Now we have one major electrolysis, and this is electrolysis of aluminium. Electrolysis of aluminium. This is electrolysis of aluminium. Okay, let's quickly look at it. The ore for aluminium is bauxite, and the ore is bauxite. We have the two electrodes made up of carbon, or you say graphite. Now, the aluminium needs to be purified. That's the first thing to be done. So you purify with sodium hydroxide. Then after purification, the next thing is is to add cryolite. Cryolite reduces the working temperature, the working system of the electrolytic circuit for aluminium extraction. So the cryolite also serves as a solvent to dissolve the aluminium. Now, by the time electricity is being passed through, it breaks down to Al3 plus and O2 minus. Now, the Al3 plus will go to the cathode and is being reduced because reduction takes place at the cathode. Then you have your Al3 plus 3 minus to give Al. Then you have oxidation taking place at the anode with 2O2 minus to give O2 plus 4E minus. Now you also remember, because the electrode is made up of graphite, the moment oxygen is produced, you realize that the anode, which is made up of carbon, will continue to deplete. Why? Because at high temperature, carbon and oxygen will react. So constantly, they will have to be replacing the anode with another graphite. Now, during the process, like I said, cathode is reduction, anode is oxidation, and the overall reaction is 2Al2O3 plus 4Al to give 3O2. Now, your molten aluminium will come out from this side. You have your molten aluminium and you can collect it. So this is how the extraction of aluminium occurs from bauxite. This is another important one. That's the extraction of iron, which is done in blast furnace. It is done in blast furnace. Now, the major ore for the extraction of iron is known as hematite. The hematite is mixed with calcium carbonate, which is your limestone, coke, and hot air is being blown in. Hot air is being blown in. Then that means you have the ore, you have the limestone. The ore is hematite, you have the limestone, and you have your coke mixed together, and you also have SiO2, which is an impurity in the process. Everything is sintered together and is known as charge. Now, it will be poured from the up part, and the molten air the air will meet it at the middle, and the first reaction that will occur is carbon plus oxygen to give CO2. The next one that will occur is carbon plus carbon 4 oxide to give your CO. This CO is the reducing agent, which reduces the hematite to iron. At high temperature, calcium carbonate always break down to give you CaO and carbon 4 oxide. Then the CaO will react with the SiO2 to give you calcium triisosilicate 4, which is known as the slag, and your iron is being produced. So this is blast furnace reaction, which produces iron. We also have another major thing we need to look at, which is purification of copper. Now, I said earlier, copper is one of the less reactive elements that we have. So most times you don't have to do electrolysis of it, and you also do not have to reduce it by carbon, but it comes on its own. You find it on its own. But the only thing is that it has impurity, so you need to remove impurity. And the process of removing impurity from it is known as electroplating using electrolysis. So this is what happens in the electrolysis of copper using copper electrodes, and that is how you can get your copper, the real form of your pure copper from the ore. Now it's time for questions. Now let's see how far we can go. Let's see how we can remember some things that have been taught either here or before or later in your class. Let's see how we can do a reminder for ourselves. Can you get your pen, get your book? I'll be asking the question. You put down the answer, you mark it yourself if you are correct or not. So let's start. Are you ready? Okay. Metals generally have, I'm waiting for you to write your answer down. Okay. The answer is high melting point. Metals generally have high melting point. Did you get it? Good. Clap for yourself. Nice. No metals have low melting point, while metals have high melting point. Next question. Beryllium, magnesium, and calcium are otherwise known as. Okay. Just write your answer down. The moment I bring out the answer, you mark it. So they are otherwise known as alkaline earth metals. They are group 2 members, so that is their name. Group 1 members are known as alkali. Group 7 are halogens. How many valence electrons does alkaline earth metal have? Yes, the answer is 2. They have 2 valence electrons in the outer shell. That is why they are in group 2. They have group 2. They are in group 2. You can see valence electrons is the outer shell electron of an atom that can form a chemical bond with another atom. So the alkaline earth metals have 2 valence electrons in their last shell. Neutral atoms of argon with atomic number 18 have the same number of electrons as Cl minus. Yes, as Cl minus. Then the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6. For argon, this is argon is 18. So Cl minus has gained 1 more electron to become 18. That is why it is 18. An element which contains no unpaired electron is said to be paramagnetic, diamagnetic, magnetic, or ferromagnetic. These are some characteristics of transition metals. So what do you think the answer is? Let's see. They are magnetic. They are magnetic. Transition metals that do not have unpaired electrons are known as magnetic. Some of them are gold, silver, mercury, and manganese. What's the oxidation number of chlorine in KClO3? Okay, let me give you some seconds to calculate it, except you know it. Quickly do the rough calculation. Let's see the oxidation number of chlorine in KClO3. That's potassium triisochloride 5. Giving you the clue. The answer is +5. +5. It has to be +5. It is when they ask for valency that you say 5. But for oxidation number, it has charges. Valencies do not have charges. So let's see how the calculation is being done. So you equate it to 0. You equate everything to 0. Then potassium is 1. The chlorine is what we are looking for. Then we have 3 oxygen, and the valency for oxygen is -2. Then 1 plus Cl minus 6 is equal to 0. Then you have Cl is equal to 6 minus 1. Then your Cl will be +5. The gas with characteristic pungent smell is Hydrogen, oxygen, carbon 4 oxide, ammonia. Your answer, the answer is ammonia. Others are odorless. Ammonia is the only one that has a pungent smell. Okay. Which of these oxides of nitrogen is often referred to as laughing gas? Yeah, try. Okay. The answer is N2O. That's nitrogen 1 oxide. That's the one that is often referred to as nitrogen, often referred to as laughing gas. It's an odorless, colorless, non-flammable gas, also known as laughing gas. Which of these halogens is a powerful germicide used in the sterilization of water for domestic and industrial use? Yes, we have said this today. Did you get it? The answer is chlorine. Yes, chlorine is used in the sterilization of water for domestic and industrial use. One major use is to kill germs in water purification, and other uses of chlorine is bleaching agent, used in manufacture of polyvinyl chloride, matches, fireworks, weed killers, pesticides, insecticide, paints, and dye stoves. Metals react by dash, losing electrons or gaining electrons. Losing electrons. Metals lose electrons while non-metals gain electrons. Lithium, sodium, and potassium are in the same group in the periodic table because they have, okay, what's the answer? They have same number of valence electrons. Elements that are in the same group have the same number of valence electrons, and they behave the same way. They will have similar properties, and they will also similar chemical properties, and they will also have similar formulae with the same elements. Sulfur bonds in air to form dash. Yes, fill in the gap. Sulfur bonds in air to form dash. A clue is an acidic oxide. Non-metals react or bonds in air to form acidic oxides, while metals react or bonds in air to form metallic oxide. If the atomic number of an element S is 19 and its relative atomic number mass is 39, how many neutrons does atom X contain? Quickly do that and give me the answer. Okay, that should be an easy one. The answer is 20. Yes, the answer is 20. Mass number is equal to protons plus neutrons, or you say electrons plus neutron. In atoms, for atoms, protons and electrons are the same. If the proton is 10, then definitely the electron is 10 for atoms. It's only in ions that it changes. So mass number is equal to 19 plus X, then your X becomes 39 minus 19, which is 20. Which is 20. Which of the following metals is the weakest reducing agent? What's the answer? Okay, let's see the answer. The answer is zinc. The answer is zinc. Metals get more reactive when they are more likely to give away electrons. Like I said, the most reactive metal is potassium, followed by sodium, followed by calcium. So zinc is a little bit lower on the reactivity series. So the more reactive they are, the more likely they release their electrons. Which of the following metals will show the highest metallic character? So I need you to guess the answer. The answer is potassium. Potassium show the highest metallic character, like I said earlier, is the most reactive elements. No, the most reactive metal. The second most abundant metal in the earth crust is iron. Iron is the second most abundant metal in the earth crust, followed by aluminium. Aluminium is number 1, iron is next, the second most abundant metal in the earth crust. Which of the following is not an ore of metals? Yes, which one is not an ore of metal? There's a mistake. The galena is supposed to be graphite, so the answer is graphite. Everyone is an ore of metal. Casterite is tin, zinc blende is zinc, galena is lead, and rock salt is sodium. Graphite is an allotrope of carbon. A metal that can be extracted from hematite is iron. Iron is a metal that can be extracted from hematite. Other ores of iron being magnetite, hematite, iron pyrites. Which of the following substances is often used in the vulcanization of rubber? Yes, the answer is sulfur. Sulfur, one of the major use of sulfur is that is used in the vulcanization of rubber. The resulting solution when magnesium reacts with water is dash. So what is formed? What solution is formed when magnesium reacts with water? Is it alkaline, acidic, neutral, or none of the above? The answer is alkaline. Alkaline. When magnesiums react, because the metal, so when metal dissolves in water, they give you base, alkaline. And when non-metals react with water, they give you acids. The process by which sulfur 4 oxide bleaches is dash, reduction or oxidation. Sulfur 4 oxide is a bleaching agent, and what process is it undergoing when it bleaches? Is it reduction or oxidation? The answer is reduction. So when sulfur 4 oxide bleaches, is bleaching power is undergoing reduction, and when chlorine bleaches, it bleaches by oxidation. Which of these metals is the most suitable to be used as lightning conductor? Which of these metals is the most suitable to be used as lightning conductor? Okay, and the answer is copper. Copper is a very good electrical conductor. All others are good conductors of electricity, but copper is the most suitable out of all of them. Which of the following is the most abundant element on the Earth's crust? Now we have looked at the most abundant metal, which we said is aluminium followed by iron. Now which one is the most abundant element on the Earth's crust? Now the answer is oxygen. Now this question is not the most abundant element in air. The most abundant element in air is nitrogen, but we are asking for the Earth's crust. So the most abundant element here is oxygen. Which of the following pairs of elements have similar chemical properties? We have sodium and potassium, we have magnesium and aluminium, we have calcium and tin, we have lead and lithium. So which of the following pairs of elements have similar chemical properties? Now, elements in the same group are expected to behave the same way. So if you look at it, the answer should be sodium and potassium. Sodium and potassium elements in the same group have similar chemical properties. Which of the following components of air can be removed by alkaline pyrogallo solution? Now, which of the following components of air can be removed by alkaline pyrogallo? The answer is oxygen. Yeah. So, in the laboratory preparation of nitrogen, oxygen is being removed by alkaline pyrogallo. And another thing that can be used to remove oxygen also is heated copper metal. Heated copper metal too can be used to remove oxygen from air. The most commonly found noble gas in the atmosphere is that's argon. So argon is most commonly found noble gas in the atmosphere. Other noble gases, or you call them inert gases, group 8 elements. Others are neon, helium, and we have xenon. We have xenon as well. These are other noble gases in the atmosphere. Another name for metalloid is, yes, we said it earlier in the class. Another name for metalloid is semi-metals. They are semi-metal. Examples are germanium, boron, and silicon. Which of the constituents of Earth acts as a diluent? Yes, we have constituents of air. We have all these are actually constituents of air, but which acts as a diluent is the question. So the answer is nitrogen. Nitrogen acts as diluent in air. Oxygen is very reactive. Oxygen is the most active, but nitrogen acts as diluent to reduce the potency of oxygen. How many electrons lost by a metal represented as Y3 plus? Yes. When metals lose their electrons, they become cations. So in this particular element, how many electrons are being lost by the metal? The answer is 3. Metals give out the electrons to become cations. Which of the following will not form positive ions? Which of these will not form positive ion? Okay, the answer should be fluorine. Fluorine will form a negative ion because it's a non-metal. Others will form positive ions because they are metals. The only metal that is liquid and at normal temperature is mercury. Mercury is the only metal that is liquid at normal temperature. And the only non-metal that is liquid at normal temperature is bromine. Bromine is only non-metal that is liquid. A process that is used for the extraction of metals in their pure form is known as, okay, I hope you are getting it. I hope you are marking it. Metallurgy, yes. Metallurgy is a process that is used for extracting metals in their pure form. Which of these metals serves as a coagulating agent in the purification of water? We've already mentioned that in the purification of water we have chlorine that kills germs. Now we are asking which of these metals serves as a coagulating agent in the purification of water. The answer is aluminium. In aluminium tetraoxosulfate 6, it acts as a coagulating agent in the purification of water. So let's look at purification of water. Now we have aeration, We have sedimentation. Aeration is when you expose it into the atmosphere and you allow the odor and some bacteria to die. Then you have sedimentation, where the sediment settles. Then you have coagulation. That's when you add your aluminum tetrasulfate 6 and it coagulates. Coagulate is that it puts all the dirt and cluster it together. Then you now have filtration, where you pass the soluble and you are left with the insoluble. Then after that, you now have your chlorination. That is when you add your chlorine to kill germs. Then after that, you do a pH check to know if the chlorine was too much or not, to check if the acidity of the water is okay for body or not. And if the pH, if the acidic, if it's a little bit slightly acidic, then you add a base like calcium hydroxide to reduce or to neutralize the effect of the acid. Which of these formulas corresponds to calcium oxide? Which of these formulas corresponds to calcium oxide? We have CaO, CaO, Ca2O, CO2, Cl2. Okay, can you quickly guess? Okay, the answer is calcium oxide. That's the answer. The valency of calcium is 2 and the valency of oxygen is also 2. By the time you swap valencies, it will knock each other off, it cancel each other, and you are left with a CaO. There is no Ca2O, there is no CaO2, and that should be chlorine oxide. Cl2O, that's chlorine oxide. Hydrogen bonds most commonly forms between which of the following? Hydrogen bonds most commonly forms between which of the following? Hydrogen and a more electropositive atom, or hydrogen and a more electronegative atom? So what's the answer? Hydrogen and a more electronegative element or atom. Hydrogen bond is a weak force of attraction formed when hydrogen reacts with highly electronegative elements such as fluorine, oxygen, and nitrogen. So hydrogen bond results from the attractive force between a hydrogen atom, which is covalently bonded to a very electronegative atom like fluorine and oxygen. Two nitrogen atoms are joined by how many covalent bonds? Okay, so the answer is 3. The answer is 3, and that is why there's a triple bond. There's a triple bond between two nitrogen atoms. For oxygen is 2. There's a double bond. For hydrogen is only 1. And for chlorine is only 1 as well. For nitrogen, there are 3 bonds that are paired by the 2 nitrogen atoms to form covalent bonds in nitrogen atoms. The following types of bonding does not involve the formation of new substances, except most times when bonding are formed, a new compound is produced, a new substance is formed. So which one does not involve the formation of new substances? Which one does not involve the formation of new substances? So we have covalent, we have dative, we have metallic, we have ionic. So what's the answer? The answer is metallic. Metallic does not result into any substance being formed. But for covalent, for example, when you have hydrogen reacting with chlorine, you have the hydrogen chloride gas being produced as a new substance. And for dative, you also have, for example, hydrogen ion reacting with ammonia, we give you ammonium ion, which is a new substance formed. And for ionic as well, ionic is when you have a transfer of electrons. So that means, for example, your sodium ion can transfer to chlorine. By the time the reaction occurs or the bonding forms, you have sodium chloride produced. So metallic bond is the only one that do not have a new substance produced. The atomic weight for aluminium is dash. Atomic weight is also known as atomic mass. We say mass number. So what's the atomic weight of aluminium? I know atomic number is 13. So what's the atomic weight? Can you guess? Okay, did you guess right? The answer is 27. That's the weight of aluminium. That's the weight of aluminium. And that's it. Thank you for today. I hope you've gained a little bit. And by the way, what did you get? Can you count what you got? Let's see. How far did you do? I hope you got 40-40, because I think I have like 40 questions there. Did you get 40-40? And you can do a whole lot more better. You can try harder. So I believe you can do more. I believe you will do more, and I wish you all the best. Thank you.